W6WUH. Okay, we're doing some the repairs off the checklist on the Valiant. So here we've put the support back in for the bleeder resistor for the power supply. You may remember from April or so we were working on this checklist, and so we're going down the list here and doing things, and today we've replaced the let's see, we're looking at the mic jack, and when you get in here you find out that this is basic screw-a-rama crazy shit, and this is where you got to go to the manual and find out how things are supposed to be. This was originally one of these, an Amphenol two-prong shielded mic plug for a plug like this. Well, this guy has decided that he's going to put in a damn four-prong Japanese mic jack. Nobody knows why. He's pulled out the key jack, the CW key jack, and he's tried to put in this good quality Switchcraft three-prong mic jack, quarter-inch mic jack. But the problem is this thing has got a little tit on it right here, and this thing is meant to have a hole or notch in the panel so that this thing cannot turn when you put it in. Well, he's trying to put it in this hole here where the old mic jack came from, and of course it goes in crooked. It can't go up flat against the chassis and put a nut on there because this tit sticks out here. And well, guess what? It's just wrong anyway. And so here's the mic wiring. It's been moved from where the two-prong Amphenol jack was over to this quarter-inch mic jack, but he can't make it work, and he's got the terminal strip all loose here, so all this crap is hanging, been moved over this jack, and it's flopping loose. And so when you get these transmitters, and people have been in them, this is the kind of crap you find. And the best thing to do is put it back to original, or if not, do something that is intelligent and that works. There's nothing wrong with having a quarter-inch mic jack here, but you got to choose one that was meant to go, well, let's see, that's a Collins plug. You don't want that one. But choose one that's meant to go flat against the chassis, and that'll work. But what's the point in putting in a quarter-inch mic jack that looks like the jack that you plug the key into? Somebody's going to grab the manual, and he's putting it in the position where the key jack was, and nobody's going to be able to figure that crap out. So I've got to take this Japanese plug out of here. I don't have any microphones that use that kind of a plug, and I don't want it. I do use quarter-inch three-prong mic jacks. It's pretty standard here, so I'm glad to have that. I can put it, if I have an Amphenol female, I can put that back in there, and that'll be the way it was originally, and use an adapter. Either one is okay. You want to put the key jack back in here. You need a damn key jack. Come on. And this is the phone patch jack, and so leave that alone. So anyway, we got to physically mount some jacks in here that are going to work. I think I'm inclined to put in a quarter-inch three-prong mic jack there. Put a two connector like a phone jack in there for the key like it originally had. So everything's in the right position. I'll probably have to use some bigger washers here to put in a 1/4-inch mic jack. But since that's standard for my microphones here, I think I'll go ahead and do it. Otherwise, I'll go back to the Amphenol and use an adapter, one or t'other. So that's the kind of crap we're finding. I replaced this SO239. This is the other kind of thing you find in old transmitters that you get cheap. Not only did this have some insect laying eggs in the center, but the center insulator is all broken. So we took that out and put a new one in there. It's not a high quality one, it's a Japanese one, but it's going to work. And so there we go. Unsoldered this, took the loading caps off, put the new jack in, got that hardware all secure, soldered the center conductor for the RFF put back up. So that's the kind of crap we're doing. We're running down the list. So I got to find a line cord. I got a line cord and put that in. Checking these off the list as we go. Mic jack, so I got to fix that. We did some of these things already. So there we go. That's basic mechanical repairs, getting all the jacks and the various stuff right. I'll get a heavy duty 3-wire line cord and put a polarized plug on it. Number 14's good. I mean, you could do a number 16, but I think a number 14 cord will be just a dandy. That's good for 15 amps. This thing doesn't draw anything like that, but going to keep the voltage drop down, makes it all work good. Well, there you see all the jackass crap that this guy put in there, trying to make the wrong jack fit in this thing. You can see how he's chewed it all up with pliers or something, trying to tighten it up. It's just, I mean, this is utter garbage. This was a good quality plug when it was in to begin with. Might even be American, but sure didn't belong in there. It didn't fit, and he had to do a whole lot of hoo-ha to do that. Trying to see if he's made this hole bigger. Looks like maybe he has. So I don't know. I'll dig in my drawer and see if I've got the Amphenol plug. One of these plugs, I think, not going to fit. So we'll see. Well, here we've removed the foreign object, this 4-pin mic jack, and because I did not have a female Amphenol to put in here right now, I took the 1/4-inch mic jack that was in there and cut the little tit off of it so that it would mount properly, and redid the wiring to it, the push-to-talk wires, and this terminal strip here was hanging loose. It had no mounting hardware, so we remounted that, stripped and resoldered the push-to-talk wires, the white ones back here, and just cleaned that business up. And then took a look at one of the notes was cut wire on the this is the transmit switch. You throw it up and it goes into transmit mode. You leave it down and it's push to talk. There was an extra wire soldered on here and clipped off. It turned out to be an addition, so we just unsoldered that, cleaned up that solder joint, and double checked it with the ohm meter that these white wires really are the push-to-talk line. So we'll be able to use our standard 1/4-inch mic jack. Oopsie. Turning into camera waving video again. Standard 1/4-inch mic jack is what I use here in the shack. And so we find a female Amphenol, we can put it back in there and make it original if anybody cares. This is the phone patch jack, which is really 600 ohm input, goes low impedance input that goes to the cathode of a second audio stage. So if you want to use broadcast standard 600 ohm audio system, you can plug it in right there. And if you want to plug in your audio generator to test the frequency response of the thing, you can plug it in right there. Makes life real easy. So this is what's been going on. We're just working down the fault list here. Oops. Okay, we've got this Valiant on the Variac, and of course there's no tubes in this thing, so there's no rectified B+. It's just the transformer across the AC line. And go watch this thing turn on and off. Not getting warm. We got dialites. We got no smoke. So cheap and dirty test just shows me that the transformer is working. It's not getting hot. It's not smoking. It's been on there for about half an hour. Not warming up, so probably okay. So let's see, wherever we are, mic jack here. It was loose with no nut holding it in. The wires were all goofy. The push-to-talk switch had a wire that was cut, so we just fixed all that stuff and crossed them off the list. So the next thing is going to be a line cord and modulator plate cap is missing. We can do that anytime. I think what we'll do next, after we put a new line cord in, is I think I'm going to test these transformers. I think I'm going to ring them now with an ohm meter. I haven't done that previously, and I should have done it before I did any work on this thing, but I didn't. So I'll ring the transformers, maybe stick them on a Variac and just make sure there's no expensive smoke coming out. And then I think we'll get on with doing the recapping. And still have to clean all these switches, all these band switches. You can see, I think you can see, rather black. So you can see how black they are. There's a little silver line there, so they're still making contact. But what we'll do is use our handy dandy eraser pencil. We put that in a too much light. Put that in a pencil sharpener. I get a fine point on it, and clean all the mechanically clean all the tarnishing and corrosion off those wafer switches. Then we'll shoot it with deoxit D5, and after we make sure we get all the little rubber particles out, and that'll make those switches good for the next million years. So we're just about through this fault list here, and so we get a line cord on it. We replace the SO239. We'll clean all the controls again. We had some plots that were frozen up. We got them loosened up. So we'll clean them with deoxit, check them with the ohm meter, and check the transformers, make sure they're just basically working okay. and then we'll get in here and replace the caps. So, a couple of electrolytics there, 2 electrolytics in that orange thing, 2 electrolytics down here in the modulator, and 1, 2, 3, 4 paper capacitors, and we're going to do the Rob Lowenstein audio mods where we'll wire around, bypass the clipper, and increase the size of the coupling caps a little bit, and I don't know if the cathode bypass caps need to be bigger, we'll do that. And I think in that mod we add another filter cap to the B plus line of the modulator to stiffen it up a little bit. Okay, take a look at this. This is an eraser pencil. It has a rubber core and it's made for erasing stuff. Now the old ones were fairly abrasive and they were used for erasing typewriter, making typewriter corrections, and I used those for years. This thing says non-abrasive, non-smudging vinyl for erasing drafting film. However, it still works for what we're going to do, which is removing the corrosion from wafer switches like this. The other thing you need is deoxit D5. You get these two things, you can clean these switches up. Here's a typical wafer switch. It's got silver contacts and they are tarnished. You can see that they're tarnished. Now when I get done with this, this is going to be shiny again. This can be difficult because you don't want to bend or damage these little wiper contacts. You don't want to fill them up with rubber crud. So when you've got the let me find the control here. Right control. Damn reflections here. Let's see if we can see this. Okay, so there's the arm, and that arm is what makes the connection with these little spring finger contacts. So you've got to get this thing in between the two contacts and rotate it some to clean it. You can see it's wiping pretty clean. So this is mostly a formality, but I just do this on all these radios and then spray it with deoxit, and then they work for 30 years without any trouble, so if you keep them clean. Okay, here you can see the difference between a switch that's been cleaned some, these two halves of the wafer on the top, and then try to look, reflection is killing me here, but look at the section of the wafer down on the bottom that I haven't really gotten to yet, and you can see the difference. Now the contact is really just that little line that the wiper makes on there, or that the contacts will make, but in order to get any of it clean, you kind of have to get it all clean. But you can see that there's quite a bit of difference here from what it was. So you ask yourself, well, what happens to these switches? They get grease and dirt on them, which is not an electrical conductor. They tarnish because these are silver plated, not gold plated. If they were gold plated, they would never tarnish. And you just spray them and never use anything abrasive on them at all. But so these are silver and they tarnish. So you can see the spring action of this contact here. As the wiper goes through it, you can see the spring lift up, so you know that it's really clamping on there, making a good contact. And then here's the common contact here that's always wiping on there, and it won't move up and down like these other contacts do. Anyway, So that's the point of doing this, is to certainly to remove any grease and dirt, and then try to remove any corrosion. And when you use this deoxit stuff, this has solvents in it, and probably a mild acid that helps remove the corrosion or the oxidation, and it leaves behind some lubrication. So tried and tested stuff. I've been using this for 30 years, and it really does work. So that, in combination with the mild abrasiveness of this rubber pen, is doing the job. Okay, while you're in here, you're going to discover stuff that's not right. Like this coupling was loose here. I had to take a screwdriver and tighten it up. While you're at that, if you want, you can zero this thing out and make sure that the knob position is right on the panel. And you can either change the knob or change the coupling, whichever is easier. But it helps to have the the knobs in the right condition. And when these things have been loose, they can get screwy. Another thing that you're going to want to do is look at the contacts on this push-to-talk relay. And going to take a little burnishing tool like this. This one comes from GC Electronics, used to be called General Cement. And it's just a little contact burnishing tool, and you can get it from a number of places. This probably came from Antique Electronics Supply a long time ago, which is also where I get the deoxit. By the way, even though this deoxit stuff is expensive, $15 plus UPS shipping, can't send it in the mail, it's expensive. But next to the new tubes you're going to put in here, spending that money on the deoxit may be the best bang for your buck they should get other than new capacitors. You really got to have this stuff. I've used it on the pots, I've used it on the switches. Here's, I think, bias pot or clamper pot. All the tube sockets are going to get it. All the plugs are going to get it. The tube sockets, the tube pins, the switches, the pots, everything that has an electrical moving contact like that is going to get deoxit on it. No magic to cleaning the contacts. Get your burnishing tool between the contacts, spray it with a little deoxit, put a little pressure on the contacts by closing the relay with your thumb, and pull the burnishing tool back and forth. Half a dozen times, something is probably going to be fine, unless they're pitted and screwed up. But just a little bit with a little pressure on there like this, and you're good to go. Here's something that's often ignored. One of the most important maintenance aspects in any transmitter like this that has high voltage on it, and that's to look. These are the rectifier tube sockets for the 866s or whatever kind of rectifier it's got. It's very important. You can see that these are dirty. You need to get a toothbrush and some alcohol or some solvent and get these things squeaky clean and inspect them visually. When these tube sockets with the high voltage on it, they can have 1,000 or 1,500 volts or whatever, depending on the kind of transmitter. They'll develop arc paths. You see this little metal ring that holds the tube socket in. Very common to find an arc path that goes from one of these high voltage wires where the filament is right down, crosses. You'll see the arc path on the ceramic and down to the metal ground. And when it does that, if you find that arc path actually has deposited metal there. As the arc goes along, it's leaving metal which embeds itself in the ceramic. And if that happens, you have no choice but either try to grind away some of the ceramic and get rid of all that metal, or replace the tube socket. So the cheap insurance is to get these things squeaky clean and keep them that way so you don't develop an arc path. You get an arc path because you have gotten dirt, and then the dirt absorbs moisture from the atmosphere, and that creates a conductive path. And when you've got high voltage, like 1,000 volts or more, it can follow that along where a lower voltage can't, and then you've got problems. So if you find evidence of an arc path, I don't see any in here, but if you find evidence of an arc path on these high voltage rectifiers, you must repair it. You've got to get rid of it. And I've done various things. I've scraped the ceramic with a knife blade. I've used what do you call it, emery paper on it, a Dremel tool, but really the cheapest insurance is unsolder the wires, put a new tube socket in there, walk away from it. But you have to do what you have to do with what you got. But to be aware of that. Okay, this grunge is stuff that came off of this tube socket. And you can still see that it's not really real clean yet. But that crud came off of there with, I took a toothbrush and rubbing alcohol and went after it. Then I took this paper towel and a small screwdriver and got in there and tried to clean some of the dirt out and dry it out. So it's cleaner, but it's still not clean. You can see somebody's done some cold solder joints on there. That's all got to be fixed. But this one has been done with the toothbrush, but nothing else. So I may go after this with detergent and water. It's going to be quite a while before this thing gets high voltage applied to it, so the ceramic will get a chance to dry out. Or I may use this stuff because it will remove most kinds of grease and whatnot. Okay, it's worth looking at how I've got this thing set up to work on it now that we're going to start doing electronic repairs on it and recapping it. So basically I've got it set upside down, and I've got a couple of little pieces of wood underneath the transformers just to make sure that we're not putting weight on this RF shielding or the tank coils, and we don't break our plate choke or anything like that. So this is perfectly secure like this, and you can get at it and work at it easily. And if you need to, you can turn the whole thing around 180 degrees and put the front panel toward you if that suits the part of it you're working on. It pays to just think about how this thing is laid out, and of course it's really laid out in sections. And this is the high voltage power supply over here, the 866 sockets. Here's the plate transformer on the back. Here's the oscillator driver section is in here, and the final amplifier is here with the loading capacitors here, and of course the coils are on the other side and the wires pass through these holes. Here's the band switch. Change the band. Over here, the low-level audio section and the low-voltage power supply. This is a power supply that gives you the B+ for the modulators, the oscillator, the driver, and this is the high voltage, and I think it's 650 volts in this transmitter, fairly low. A lot of similar transmitters would be up around 750, and in the Globe Champ 900. So that's the deal. When we recap it, we're going to be doing the filter caps in the low voltage supply, the filter caps in the high voltage supply, and the coupling and bypass caps in the audio section. So that's basically the deal. And as you go through and look at stuff, I just found these resistors smashed over here against these pots. Well, you want that's a 5-watt pot that gets hot on its own. It doesn't need any more heat. So just put these resistors out so they can cool. The same thing with these things. I've got them bent out of the way just so I can work on it. But let these things have as much air as they can. And if you've got something like a big power resistor, you know it's going to get hot. Don't put it right up next to the filter cap and blow that up. And you know, I found this RF choke and this capacitor smashed over against this little oscillator coil. Well, that's dumb. So this thing, oh, I know the thing I wanted to look at. This thing was a kit. If you look at the model number on the back, you can see it says -1. That means it's a kit. So, is that bad? Well, let's take a look at how this guy built it. There's nice solder connections, no sloppy solder, no cold joints. The wire dress is basically good. Of course, this thing has a big, what do you call it, BDDD, can't talk, but anyway, the basic construction was good. But what we found is that somebody later on came in and did screwy stuff that we had to fix, like this mic jack and you know, some other junk. So we're going to be on the lookout for this. Somebody's tried to recap this and done a very poor job with cold solder joints that weren't part of the original construction, and just a funky everything when he tried to recap the power supply. So you just be on the lookout for that stuff, and when you find it, fix it. I've been showing you my old original provisional notes, but I had actually made a reasonably clean checklist to go down, and so I'm working with that checklist now. This is what happens when you set something aside from April to December or November. You forget a lot of the stuff that you've done. So in this case, I forgot that I had made better documentation for the work that I'm going to do on the thing. So anyway,